Okay. Let's have a look here. This question seems quite interesting to me. So we don't want to use um, Newton's method. Um, well, yeah, we want to use the original function. Now, I think this relates somewhat to the idea of an attractive fixed point. Possibly, maybe not. Because we also want to have convergence. So, let's see. So basically, we're looking for the square root of 2. So let's say we make a guess. So we'd say xn equals the true root, which is root 2 plus epsilon, which is a small number. So if you square this, you'll get... No, I don't think that's going to work. Let's think about this now. What would happen if I use Newton's, though? So, like, Newton would have said xn plus 1 equals xn minus f derivative, which is 2xn, all over xn squared minus 4. But that in no way relates to the original function. What I could do... This should be quite small. Should be quite small. So if... yeah. So maybe if I change this to a plus, and that the 4 minus xn squared, and that's equal to xn plus 2xn times 1 over 1. No. Hmm. 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 What to do? What to do? Let me pause. Right, that was a 30-second pause, sip of coffee. I feel like I would like to do something risky, like partial fractions, and I'm going to go back to the minus. So okay, xn minus 2xn xn minus 2 plus xn plus 2. No, I'm going to try. Sorry, I keep messing around here. I'm going to try taking out xn squared, and that's 1 over 1 minus 4 over xn squared. Xn squared, no, that's too big. Okay. There is another technique I can think of, but it could kind of work here. It's what I was saying earlier about attractive fixed points. So you have the equation fx, this is 411 now, fx equals x squared minus 4, which you want to equal 0. So that means x squared minus 4 you want to equal 0. And if you add x to both sides, equals x. So this equation here, this equation is of the form of, let's call it gx equals x. And in fact, when you have an equation like this, in certain situations, it's possible that the function g is the function that takes you closer to the solution. So you could actually have this equation, xn plus 1 equals gxn, and xn plus 1 would equal xn squared plus xn minus 4, and that's xn plus 1 equals xn plus xn squared minus 4. So that means xn plus 1 equals xn minus c. Well, I'll just put it like this. Plus, and that's the original function, fxn. So xn plus 1 equals xn minus c fxn. That would mean c equals minus 1. Now I can test this theory out by trying some value close to 0. So if I try x0 equals 0, let's see what I get for x1. No, that doesn't work. That doesn't work. I think it's the starting point that might be the problem. Maybe. No, that's not the problem. So I'm actually a bit flummoxed by this question. Let's try it again. And I'll pause again. So I think the problem is the C. Maybe I have to take just this as a starting point and try and figure out the C later. So let's try this again. Xn plus 1 equals xn minus c, xn squared minus 4. Okay, so if we start off with x0 equals 0, then x1 would equal 0 minus c times 0 minus 4, which equals 4c. Then x2 would equal 4c minus c, 16c squared minus 4. So then x2 would be 4c plus 4c plus, no, minus 16c cubed. Okay, and that's equal to 8c minus 16c cubed. If I continue up here, that would be 8c, 1 minus 2c squared. I really think that helps. And I think that's enough to at least get a rough value of C. I want 8C minus 16C cubed to roughly equal the solution here, which I know is 2. So that means I want 4C minus 8C cubed to roughly equal 1. So C is roughly equal to minus 0.809 or half. Okay. Half maybe. Let's try it out now. Xn plus 1 equals xn minus a half, xn squared minus 4. Okay. Oh, yeah. That gets you straight there. So, okay. C equals a half. That works. Works really well, actually. And I know from earlier, it didn't converge when C was minus 1. That fails. I wonder what the answer at the back is. Yeah, okay, so more than a half fails and less than or equal to a half works. And it just says find a C, so that's enough. Yeah, okay. I think getting my head around this a little bit now. So if we do something similar for 412, we can say xn plus 1 equals xn minus C times xn squared minus 4xn plus 3. And we start off with 2. So x1 equals x0 and 2 squared minus 8 plus 3. So that's 2 plus C. And if we just take one iteration, that should roughly equal the solution here, which is 1 and 3. So, yeah, I need the C. So I could maybe have C equal to 1 plus or minus 1. That could work, maybe. Let's see. Answer. Yeah, that worked. Yeah, that works. So plus or minus 1 definitely works. And actually, I realize now that one iteration was enough. So I could have stopped sooner, earlier. I could have stopped like here. I could have said 4C needs to roughly equal to 2, which means C is about a half. So that's fine. So one iteration works. Okay, good. Now what about a value that fails? I'd imagine if it's too big, like maybe a 2. 2 is not going to work. I feel like if it's bigger than outside plus or minus 1, it's not going to work. And then this should work, and this should fail. Let's see, oh, it's no answer at the back for this one. Okay, and then 413. What value C for Newton's method? Well, the C equals 1. Good question. I guess it's kind of like 1 over fxn f derivative xn. No, sorry. Just 1 over f, yeah. Yeah, but that's not really a constant. So, the answer say, yeah, but C isn't a constant. It's C, not CXN. I don't know. Should I open a ticket about that? Is that too pedantic? What do you think? We'll leave it there today.